Welcome back. This is the third and likely last segment for section 7.3, which will be the last video for course unit 2. So after we complete this section, the expectation is that there'll be some kind of a test over the last few sections, including 7.1, 7.2, 7.3, and likely, depending on exactly how the semester gets divided up, typically it's 2.3, 2.4, and then a little bit in 2.5. So my suggestion, just kind of as an aside to that, is that the way to typically the examination over this particular material, people tend to do pretty well. However, you do need to practice this to get really proficient, because it's easy to make kind of mistakes and whatever else. But the reason why this is easier material is because the process is relatively straightforward. It's do this, do this, do this, do this, and out comes the answer. The only places where that are a little bit strange is with the ambiguous case of law of sines, which I have found over the years that is where people struggle the most. But for the law of cosines, it's relatively straightforward. You know, side angle side, side side side, angle side angle, and angle angle side. Those are the easy ones to sort of pull out, because it's just, okay, go to this method, do this method, and I don't have to think about what to do. I'm just calculating. So the errors that I see in people's homework and their tests is actually calculator errors. You know, messing up a number here, a number there, and then it sort of cascades into a bigger mistake. But with the side side angle, that's really the one that you have to think about what's going on a little more carefully. But besides that, let's move over here and deal with the last kind of scenario that I wanted to address, which is the side side side. And in the process of doing that, I did mention in the last segment that there are situations where you can create a so-called a situation where there's no solution. But let me just kind of real quickly sort of illustrate where that comes from. So if you had, and I'm not going to necessarily draw it, but let's say we have a side 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 situation. Now notice that if you want to create a triangle, the sums of the lengths of the two sides that aren't drawn currently have to be at least as long as the side that is drawn. If they were shorter somehow, then you wouldn't have a triangle, and in fact they wouldn't meet. So that's something in mathematics that's called the triangle inequality. And the way you can think about it is, if you go directly from point A to point B, right? So maybe this is A and B, that is the shortest distance between A and B. It's a straight line, right? That sounds pretty prophetic, but you've heard that before. Any other path, which is where your triangle is created, must be longer. Okay, so that's the only situation in which you have no solution for side side side, is if for some reason the direct path is actually longer than some sort of circuitous path. It's kind of a weird situation. And as soon as you start trying to solve this, you're going to find that it doesn't work very, very quickly. So remember, side, side, side is the situation where I know all three sides. And I'm just going to pick something that seems reasonable. How about C equal to, let's say that's, oh, I don't know, let's say 85 feet. B looks to be shorter, so B, let's make that 62 feet. And A, let's maybe say 56 feet. Okay, so we will use exclusively version 2 of the law of cosines, and we will do the calculation 3 times in a row to arrive at the result. So let me just maybe kind of preface this, that this is the second segment, but side, side, side. So here's our situation. How do we go about doing it? It's very mechanical. We start with angle A. So angle A is going to be the inverse cosine of, and remember, it's the other two sides. So B squared plus C squared minus A squared all over 2BC. Plugging those numbers in. I don't need to use the store function on my calculator because these are relatively easy numbers. So 2 times B times C well, maybe it'd be easier to start with the numerator in this case. So I've got 62 squared plus 85 squared plus minus 56 squared equals, then I'm going to divide that by 2, divide that by b, which is 62, and then divide that result by c, which is 85. And there's a number, that's the argument. That's what's inside the parentheses. And since it is in the range of cosine, there's no problem there. Hopefully we haven't fat fingered something. So I will take the inverse cosine, and there's the angle. So 41.17897 687 and etc. So we'll hold on to that for a second. Let's I'm kind of run up. I started on the same page. I'm still on page 4, so I'm going to move to the move to another page here and continue with the calculation. So section 7 page 5 now. So the next computation is to find angle B, which again is the inverse cosine of a squared plus c squared minus b squared over 2ac. And so recall a was 56, so 56 squared plus c, which was 85 squared, minus b, which was 62 squared. That's our numerator. And then divide by 2, divide by a, which was 56, and then divide by c, which was 85. So there's our argument. And it's in the range of cosine, so we should be able to take the inverse cosine, and there's our angle. 46.79907,901 degrees. Okay, so usually at this point, you could just add both of those together, subtract it from 180, and find the third angle. But it doesn't give us any redundancy. It's easier just to keep going. Maybe you could calculate it a different way, but I tend to not want to jump to the the sum of interior angles equal 180, because that's easy to check at the end. So I will go ahead. Typically, I will just go ahead and do the third calculation. So inverse cosine of, so c is equal to inverse cosine of a squared plus b squared minus c squared all over 2ab. So again, let's see, a is 56 squared plus b 62 squared. Subtract from that c, which is 85 squared. That's our numerator. And then divide by 2, divide by a, which is 56, and then divide by b, which is 62. And notice this is a relatively small number, but it's negative. And it turns out that this is actually because this is a obtuse angle. And it's close to 90 degrees, which you could have seen if you just added up the other angles. You'd get around 90, 92, 93 degrees or whatever. So, but it is in the range of cosine, and there we go. It's 92.02194413, etc. degrees. So the question then is, how do we round these? Well, note that every one of those distances had 2 significant digits, so the result has 2 significant digits, and that makes this a pretty straightforward problem. So A, when I round it, is 41 degrees. B, when I round it, is 47 degrees. And C, when I round it, is 92 degrees. And then, of course, the distances that were given in the problem, A is 56 feet, B is equal to 62 feet, and C is equal to 85 feet. Now, what I was talking about in terms of checking to see if I've made a mistake, I mean, this isn't super accurate. It's only accurate to the degree. But if I've blown this somehow by putting in the wrong number, it's going to be probably way off. It's not going to be very close. It'll be completely off. So what I might do is I might add up this. Let's just note that A plus B plus C happens to equal 41 plus 47 plus 92, which, when you do this computation, equals 180 degrees. So that's my check. And I have verified, at least I have some confidence that the angles I wrote down are correct. Okay, so this one, like I said, the stuff in section 7.3 is a little more challenging because the formulas are more difficult. But if you can remember the formula, you just kind of permute it with the A, B, and C in different orders. The one that is more technically challenging is actually section 7.2 because you have to remember some different criterion that isn't just as simple as memorizing a formula. Of course, the problems in 7.1 are without a doubt the easiest, and most people have really no trouble doing those in a testing situation. So as I said, this is the last segment for 7.3. It is also the last section for this unit. And so the next step would be to take the test for these last couple of sections. So good luck, and I will see you in with the next videos will be for chapter 3.